Here in the second part of section 5, we're going to be talking about using exponents that are fractions. And any number raised to a fraction can be rewritten as a radical. So when you do have an exponent that's a fraction, the numerator is going to be the exponent, and the denominator is going to be the root. Here's what it'll look like. Let's say we have the square root of 9. Well, 9 is raised to what power? Well, it's got an exponent of 1, doesn't it? But what's not, the other thing that's not written here is a number right up here, and it's called the second root, or we commonly say the square root. So 9 can be written as a, the square root of 9 can be written 9 to the 1/2 power. Because the numerator is going to be the exponent, so the exponent is going to be the numerator, and the root here is going to be the denominator. So that's how you're going to rewrite anytime you have a number raised to a fraction. Let's look at x to the 1/2. Well, again, the numerator is going to be the exponent, so we're actually talking about x to the first power. And then I want the second root. Well, usually we don't write the number 2 here because we're already talking about the second root, the square root, and we don't write exponents of 1. So actually, class, x to the 1/2 power is written the square root of x. Same thing. Let's look at number 2. What number goes inside the 3? So now, x is always the base. And I mean, it's always going to be the base in this problem. We have x to the what power? Well, to the third power. And we're looking for the square root. We don't write the 2. We could put that 2 here. That means the square root of x to the third. Now, we would need to simplify this. Well, what is x to the third power? Well, x times x times x, right? For every 2 factors that are the same underneath, I can pull 1 out. This guy stays behind, like we've been discussing all along here. So actually, x to the 3/2 power, x radical x. And we can do the same thing. It doesn't have to be a variable. In this case, problem number 3, 4 is the base. What's the exponent? 1. We don't write the 1. The root is 2. We don't write the 2, but what we're actually looking at here is the square root of 4, which is 2. Try plugging that into your calculator. You know how to do that? Oh, wrong one. Here we go. Let's clear all this stuff out. All right, so 4 to the 1/2 power. We're going to press your 4. Now your exponent button is this caret key. It looks like the roof of your house. So 4 raised to the, and now we're going to do the 1/2 power. So we're going to do 1 fraction 2. It's the same thing as taking the square root of 4. And actually, you can use that, use your calculator every time if you'd like, if it comes out to be even. Sometimes they don't. And if they don't, they're going to have to work it out manually. So if you were to take 5 and raise it to the 2/3 power, you wouldn't get a very nice number. So what we would do is we would have to simplify this one by hand. So we're looking at 5 being the base, and the exponent is 2. This time we're looking for the cube root. So we're going to have to put a 3 out there. Now that means we're going to be looking for 3 factors that are the same underneath the radical to be able to pull 1 out. Before, When we were just dealing with square roots, we were looking for two factors to be the same. We're looking at the square root here. Two factors are the same. Now we're looking for the cube root. Now we need three factors that are the same. So when I write the prime factors of 5 squared, I would just get 5 times 5, right? Do I have three factors here? No, I don't. So we would multiply the 5 and the 5 back together again. We're talking about the cube root of 25 is how that would be read. The cube root of 25. All right, number 5. We have 9 to the third power. But now we're looking at the fourth root. Remember, this is the inside number, the exponent. 4 is the outside number, the root. So now I need four factors that are the same in order to be able to pull one out. So 9 to the third means 9 times 9 times 9, right? And each 9 is 3 times 3, right? So this first 9, 3 times 3. The second 9, again, 3 times 3. The third 9, 3 times 3. Now I'm looking for the fourth root. So this 4 always stays there. I'm looking for four factors to be the same. Here are those four. So I pull one of those out. I don't have another set of 4s. I only have 3 times 3 left over. So I'm going to have the fourth root. 3 times 3 is 9. And this is your answer. It's red. 3 times the fourth root of 9. Go ahead and take 27 raised to the 1/3 power. What do you get? Use your calculator. You should be getting 3. Here's what it means. It's 27 to the first power. I'm looking for the cube root of it. What this is saying is I'm looking for a number that when you take it times itself 3 times, you get 27. Well, the prime factors of 27 are 3 times 3 times 3. Now I'm looking for three factors that are the same to pull one out. There's your answer, 3. 3 times 3 times 3 is 27. That's what we're looking at. Go ahead and take 16 and raise it to the 3/4 power. What do you get? You should be getting 8. That's because you have 16 to the third power. We're looking for the fourth root of 16 to the third, which means the fourth root of how many 16s? 3 of them, right? Well, 16 has what prime factors? 2 times 2 times 2 times 2. So we need the fourth root of, how many 16s do I have? Well, I have 3 of them underneath the radical. So here's the first 16. 2 times 2 times 2 times 2. Here's the second 16. Another 2 times 2 times 2 times 2. And here's the third 16. 2 times 2 times 2 times 2. Now I need 4 that are the same. Here are 4 2s. I pull one out. I have 4 2s. I pull one out. I have 4 2s. I pull one out. I don't have anything left over underneath the radical. So my answer is just 2 times 2 times 2, which is 8. In number 8, I'm looking for, what I'm really looking for when I say the 8 to the 1/3 is the what? The cube root of 8. What times itself 3 times is equal to 8? 2. What's 7 raised to the 2/3 power? Well, we're looking for the cube root of 7 squared. So now I need 3 factors that are the same underneath the radical to be able to pull one out. I don't have that, do I? No, I only have 7 times 7. So your answer would be the cube root of 49. 8 to the 4/3 power? 16. Number 11, 6 to the 3/2 power? we're looking for the square root. I'm not going to write the 2. We could write the 2 here, right? But it's not necessary because when we don't write the 2, it's already assumed to be the 2. So we're going to leave it just as the radical, and we're needing 6 to the 3rd power. Well, let's have the prime factors. Now, each 6 is 2 times 3, right? But I have 3 of them, so I need 2 times 3 times 2 times 3 times 2 times 3, which means underneath the radical, I'm going to have 2, 2, and 2, 3, 3, and 3. For every 2 that is, because I'm looking for the square root right now, right? I'm looking for the square root. Every 2 that are the same, I can pull 1 out. This one stays behind. Pull out a 3. This one stays behind. So outside I have 2 times 3 is 6. Inside I have 2 times 3 is 6. Your answer is 6 radical 6. Try 3 to the 5 halves on your own. Stop the video right now and work this out and see if you come up with the same thing I do. When you have it done, restart the video. I came up with 9 radical 3. Hopefully you did too. If you didn't, look at what I have written down, look at what you have written down, and see what the difference is. Next page. Number 13 would just be the cube root of 11. Number 14, look at what we have. We have 4 to the 4/3 power. That would be to the 3rd root of 4 to the 4th. Oh my goodness. Now, 4 is 2 times 2, right? And underneath the radical, how many of them do I have? I have 4 of them. So I need 4 sets of 4. So one of them is 2 times 2. Another one is 2 times 2. Another one is 2 times 2, and yet the 4th one is another 2 times 2. So we're looking at the cube root of 1, 2, 3, 4, 5, 6, 7, 8 2's. 1, 2, 3, 4, 5, 6, 7, 8. Now, every 3 I get to cross out and bring 1 down. So I have a 2 times 2. I don't have 3 more 2's here, so I multiply those back together, and I have outside 4, and remember this is the cube root of 4, final answer. Look at number 15. We're looking at the cube root of 12 squared. Well, 12 is equal to what are the prime factors? 2 times 2 times 3. And I have 2 of them, right? I mean, it's squared, so I have 2 of these 12s times 2 times 2 times 3, right? So I'm looking at the cube root of 4 2's and 2 3's. Just write out all the prime factors. And I'm looking for 3 of them to be the same to be able to pull 1 out. Here's 3 of them. I pull out a 2. I'm looking for the rest of it. All of these go back underneath because I need 3 to pull 1 out, and I don't have 3, so I'm going to be multiplying 2 times 3 times 3 back together again. So I'm going to have as my final answer 2 times the cube root of what? 18. Final answer. You do number 16, 17, and 18 on your own. See what you can come up with and see if you get the same answers as I do. Again, pause the video and then restart it again once you've come up with your answers. All right, at number 16, I came up with 3 times the cube root of 9. Number 17, 6 radical 6. Remember, we just did this one, right? Did you come up with the same answer that we had on the last page? Number 18, 27 radical 3. There's how we do those. And actually, sometimes you can just plug these into your calculators. What's 81 to the 5/4 power? Let's see if it works. Let's clear all this out. 81 to the 5/4. We're going to take 81 and raise it to the 5/4 power. Oh, look at that, 243. Let's try 3125 to the 2/5 power. 3125. We're going to raise that to the 2/5 power. Enter. Oh, here we go. 25. And how about 343 to the 1/3 power? 343, we're going to raise that to the 1/3 power, and we get 7. So looks like those last three came out nice and even for us. Made it easy on us just to plug that into your calculator. But if you can't plug it into the calculator, you're going to have to do like something like numbers 16, 17, 18, 14, and 15. We're going to have to write out those prime factors and then start pulling out however many factors you need. So there you have it on section 5, second part, the fractional exponents. Hope that helps. Good luck on any assignments that you have, and we'll see you in class. Have a good one.